Imagine a traveler from the intergalactic void, an object that shouldn't be here, coming from a darkness that stretches for light years. It crossed billions of kilometers of interstellar space, and in 2025, it approaches our solar system. Not as a friendly messenger, but as a cosmic anomaly, a frozen and silent mystery. This is Comet 3, IATLAS, the comet that shouldn't exist. In this dive into the depths of the unknown, we'll unravel. First, what makes 3I Atlas a cosmic impossibility? A chemical composition that defies 4.5 billion years of knowledge about comets. A ratio of carbon dioxide to water 8 times higher than any comet ever observed. Second, the unsettling discovery that confirmed its origin beyond the stars. A relentless hyperbolic orbit coming from the densest region of the Milky Way, traveling at speeds that defy human comprehension. Third, the frozen mystery of its alien composition. Water, ice, carbon monoxide, carbonyl sulfide, and something more. Something that the James Webb Space Telescope revealed that could rewrite our understanding of planetary formation. Fourth, why it defies the most established theories. Its size, its activity, its chemistry, everything points to a formation environment radically different from our solar system. And fifth, what happens when it disappears forever. After October 2025, it will cross to the opposite side of the Sun and head into interstellar void, taking with it secrets from distant worlds that we may never reach again. In 2025, humanity witnesses a rare and perhaps disturbing event. 31ATLAS is the third confirmed interstellar object to cross our cosmic backyard. Before it, we had the enigmatic Oumuamua in 2017, an object without a tail, with inexplicable acceleration that some dared to call alien technology. Then, in 2019, Comet Borisov, the first confirmed interstellar comet, with chemistry surprisingly similar to our own comets. But Atlas is different. With its relentless hyperbolic orbit, it came from afar, made its solitary passage, and will never return. A unique chance to glimpse a fragment from another universe, a fleeting opportunity to unveil secrets that have floated through the void for unimaginable ages. And if we don't capture every photon of light, every molecular signature, every fragment of data, it will be lost forever in the dark vastness, taking with it the chance to rewrite our understanding of the cosmos. The clock is ticking, and the window is closing. It all began on July 1st, 2025. The skies of Chile, under the tireless watch of ATLAS, the Asteroid Terrestrial Impact Last Alert System, revealed an anomaly. A faint point of light, but in motion. The system, designed to warn of asteroid threats near Earth, registered something that didn't fit familiar patterns. Initial images dating back to mid-June were recovered from the archives, and orbital calculations began. Astronomers around the world turned their instruments toward this mysterious visitor. Each telescope, each observation, added another piece to the puzzle. With each new measurement, the truth became clearer, and more shocking. The object's orbit wasn't elliptical, like our comets and asteroids that orbit the Sun in predictable cycles. It was hyperbolic. This means its velocity was so extreme, so far beyond what's needed to escape solar gravity, that it wasn't trapped in our system. It was just passing through. An unmistakable signature, irrefutable mathematical proof. It came from another star system. It was an interstellar visitor. The third confirmed in the history of modern astronomy, but there was something even more disturbing behind this initial revelation. When astronomers scoured archives of previous observations, they found records of the comet dated June 14, 2025, almost 3 weeks before the official discovery. It was there, hidden in the data, waiting to be found. How much longer did it go undetected? How many other interstellar visitors have crossed our system without being detected? And when they reconstructed its incoming trajectory, the origin revealed itself to be even more unsettling. Where exactly did it come from? And what can its journey through the interstellar void reveal about the nature of the universe? Before Atlas, we had 2 other messengers from the abyss. Each of them rewrote what we thought we knew about interstellar visitors. October 2017, the Pan-STARRS telescope in Hawaii detects an unusual object. Its shape was bizarre, elongated, like a cigar or a flattened pancake, depending on interpretation. But the most disturbing thing was its behavior. It was accelerating inexplicably, without showing signs of cometary activity. No coma, no tail. Just a solid object, accelerating through space for unknown reasons. Some scientists proposed it could be a hydrogen iceberg. Others suggested a natural solar sail. And some dared to whisper about alien technology, an interstellar probe from a distant civilization. The debate continues to this day. August 2019, amateur astronomer Gennady Borisov in Crimea discovers the second interstellar visitor. But this one was different. To eye, Borisov displayed a clear coma and tail, a classic comet. Its chemical composition, analyzed by telescopes around the world, proved surprisingly similar to comets from our own solar system. Water, ice, carbon monoxide, cyanide, the familiar building blocks. This gave us hope. Perhaps interstellar comets weren't so different from ours. Perhaps the chemistry of planetary formation was universal. July 2025, 3I ATLAS arrives to complete this triad, and it defies both expectations. Unlike Oumuamua, it displays a clear coma and tail, confirming its cometary nature, full of volatiles. But unlike Borisov, which closely resembled comets from our own system, ATLAS carries with it nuances that could rewrite what we know. Each of these visitors is a cosmic time capsule, a fragment from a distant protoplanetary disk ejected by forming gas giants, launched into the interstellar void to wander for millions or billions of years. And now, by pure chance, their trajectories have crossed ours. But where exactly did Atlas come from? And at what terrifying speed is it traveling? When scientists reconstructed its incoming path, the point of origin seemed to emerge from the Sagittarius region. The comet is coming from a dense area near the Milky Way S-bulge, a region rich in ancient stars, dark nebulae, and cosmic mysteries. One of the densest and most chaotic regions of our galaxy, its speed is staggering, approximately 61 kilometers per second, which equals a mind-bending 221,000 kilometers per hour. To understand what this means, that's almost 70 times faster than a hypersonic missile. It's 180 times faster than a commercial airplane. It's a speed that defies human comprehension. Its closest approach to the Sun, perihelion, is predicted for October 30th, 2025. At a distance of about 1.4 astronomical units, a bit farther than Mars's orbit. At that point, the Sun's heat will be sublimating its ices at extreme rates, releasing gases and dust in a spectacular display. And Earth, we're safe. The minimum distance from Earth will be about 1.8 astronomical units, approximately 270 million kilometers. No impact risk, no threat. But this is our only chance to study it, because after perihelion, it will continue on its relentless path. It will cross to the opposite side of the Sun at the end of October and head out of the solar system, accelerating back into the interstellar void. Its hyperbolic velocity will ensure it escapes solar gravity. It will never return. In a few years, it will be beyond the reach of our most powerful telescopes. In a few decades, it will be beyond Pluto's orbit. In a few centuries, it will be crossing interstellar space again. And in a few million years, perhaps it will encounter another star system. Perhaps other civilizations will observe it, just as we do now. Or perhaps it will wander the void forever, a solitary traveler in the cosmic darkness. But when humanity's most powerful telescopes observed it up close, what they revealed was even more disturbing. The sharp eyes of the Hubble Space Telescope wasted no time focusing on 3I Atlas. On July 21, 2025, when the comet was 277 million miles from Earth, the first high-resolution images arrived, and they revealed an undeniable truth. The object wasn't just a chunk of interstellar rock, it was active. Hubble captured the unmistakable teardrop-shaped coma and a dust tail, confirming that this cosmic traveler was, in fact, a comet. Its ices, heated by the Sun's growing proximity, were sublimating, releasing gas and dust into the vacuum. This means Atlas offers us an unprecedented opportunity to study the composition of a body formed in a different star system. Not just theories, not just computer models, but real data, real light, reflected and emitted by a fragment from another world. And then, the James Webb Space Telescope entered the scene. On August 6, 2025, using its near-infrared spectrograph, Webb observed 3I Atlas with unprecedented precision. It searched for specific molecular signatures, the chemical fingerprints that would reveal the building blocks this comet brings from a distant stellar cradle. And what Webb found was extraordinary. The comet's coma was dominated by carbon dioxide CO, but not just dominated, the ratio of CO2 water HO was 8:1, 8 times more carbon dioxide than water. This is the highest ratio ever observed in any comet. Typical comets from our solar system have much lower ratios. Some have more water than CO, others have balanced proportions. But 8:1, that's extreme, that's anomalous. That suggests something profoundly different about the environment where Atlas formed. Perhaps it formed near the CO ice line in its protoplanetary disk of origin, a region where carbon dioxide freezes, but water is still in gaseous form. Or perhaps it was exposed to intense radiation from its parent star, preferentially evaporating water and leaving CO behind. But there was more. Webb also detected carbon monoxide, CO carbonyl, sulfide OCS, and dust in the coma, a complex mixture of volatiles and solids, and alien chemistry, literally. But the most disturbing discovery was still to come. The size of Atlas defied all expectations. One of the first questions about any new comet is, how big is it? In the case of 3I ATLAs, the initial answer was, at best, vague and unsettling. Hubble's preliminary estimates pointed to a diameter that could range between 320 meters and 5.6 kilometers. A massive margin of error. Why such huge uncertainty? Because we're talking about a newly discovered object hundreds of millions of kilometers away, obscured by the very coma that makes it a comet. The amount of light it reflects, the activity it displays, the dust it releases, ... All of this makes it difficult to discern the exact size of its frozen nucleus. But even with this uncertainty, one thing is clear. 3I Atlas could be larger than 2I Borisov, which had a nucleus of a few kilometers, and certainly much larger than 1I Oumuamua, which measured in the hundreds of meters. If the upper estimates are confirmed, we'll have an interstellar colossus before us, a frozen giant, traveling through the void for unimaginable ages, carrying with it secrets from a distant star system. As the comet approaches perihelion, continuous photometric observations are refining these estimates. Each brightness measurement, each analysis of gas and dust production rate brings us closer to the truth. But the uncertainty remains, and with it, the mystery. What we know is that at the heart of this comet, there's a solid nucleus of ice and dust, a frozen fragment from a protoplanetary disk that existed billions of years ago, around a star we may never identify. A piece of cosmic history preserved in the absolute cold of interstellar space. But the real mystery wasn't just in the size ... It was in the alien composition that defied everything we knew. If you re-immersed in the mysteries of the cosmos and want to continue unveiling the deepest secrets of the universe with us, don't forget to like this video. Subscribe to the channel so you don't miss any of our journeys into the unknown, and hit the bell to receive notifications. The universe calls to us, and together we will answer. Now, let's dive even deeper. The cometary activity of 3I ATLAS confirms it's rich in volatiles: water ice, HO, carbon monoxide CO, and carbon dioxide CO mixed with cosmic dust. But the exact proportion of these elements, the molecular signatures that James Webb and other telescopes are searching for, could be the key to unlocking its history. Comets from our own solar system are time capsules from the era of their formation, 4.5 billion years ago. They tell us about the environment of the young sun, about the temperatures and pressures that existed in the outer regions of the protoplanetary disk, about the processes that led to the formation of giant planets. 3I ATLAS, in turn, is a time capsule from another stellar nursery. It may contain isotopes and molecules that are rare or non-existent in our comets, indicating a formation environment with fundamentally different temperatures, pressures, or even chemical composition. That extreme ratio of 8:1 CO2 water, it tells us something profound. Perhaps ATLAS's parent star was hotter or cooler than our sun. Perhaps the protoplanetary disk had a different chemical composition, with more available carbon. Or perhaps radiation processes or collisions altered the comet's chemistry during its interstellar journey. This will give us a direct sample of the material that formed planets in a distant star system. We don't need to travel light years. The universe brought the sample to us, and a deep analysis could rewrite our models of planetary formation and even about the origin of life. Because if interstellar comets carry such diverse chemistry, if each star system produces its own unique building blocks, then the chemistry of life could be much more varied than we imagine, and the chances of life on other worlds could be much greater or much stranger than our current theories predict. But even with all this technology, with all this data, the deepest questions remain unanswered. Even with all the technology at our disposal, 3I Atlas raises more questions than answers, and perhaps that's what makes it so fascinating. So disturbing could it contain exotic isotopes, elements that would only form under extreme conditions, indicating a parent star very different from our Sun, perhaps a more massive star with different nucleosynthesis processes, or perhaps an older star formed when the galaxy had a different chemical composition. What will its composition tell us about the rate of gas and dust production in an alien system? How do comets behave when formed under different conditions? Sublimation follows the same physical laws, but the results can be dramatically different. What were the conditions of the protoplanetary disk that ejected it? How many giant planets existed? How massive were they? And what was the chaotic gravitational dance that launched Atlas into the interstellar void? There's also constant vigilance for possible brightness outbursts, or, more dramatically, the comet's fragmentation. Comets are fragile objects. The gravitational and thermal stress of passing by the Sun can disintegrate them. If that happens, it would release its secrets even more dramatically, but also more chaotically. Each day of observation is crucial because 3IATLA is an ephemeral window into a universe beyond our own. The optimal observation window is closing. In October, it will be too close to the Sun in the sky for ground-based observations. In December, it will reappear on the other side, but will already be moving away, getting fainter each day. And when that window closes, when it disappears beyond the reach of our telescopes, the secrets we couldn't unveil will be lost, perhaps forever. And so, what does all this mean? For science, for humanity, for our understanding of the universe? 3I Atlas isn't just an astronomical curiosity, it's a living testament to the incredible diversity of the universe. Every observation, every piece of data collected, is a fragment of knowledge that allows us to assemble a cosmic puzzle of epic proportions. It forces us to expand our minds, to question what we consider standard, and to recognize that the formation of stars, planets, and perhaps even life, takes forms and chemistries we've barely begun to imagine. This comet is a free sample from a universe much larger than our small solar system. It's a window into processes occurring on galactic scales. It's proof that the universe is in constant motion, with objects crossing the void between stars, carrying information from one system to another, and it prepares us for the future, because 3I Atlas won't be the last. As our telescopes become more sensitive, as survey systems like ATLAs and the future Vera Rubin Observatory come online, we'll detect more interstellar visitors. Perhaps dozens per year, perhaps hundreds, and each of them will teach us something new about cosmic diversity, about the chemistry of planetary formation, about conditions in other star systems, and perhaps about the chances of life beyond Earth. To summarize the most disturbing facts about this phantom visitor, first, its interstellar origin is confirmed by a hyperbolic orbit that defies solar gravity. It came from another star system, traveling at 221,000 kilometers per hour. Second, it's the third and most recent messenger from other worlds and will never return. After October 2025, it will disappear forever into the interstellar void. Third, it could be larger than its predecessors, Oumuamua and Borisov, a sleeping giant awakened by our sun's heat. Fourth, its composition is a mystery to be deciphered. A CO2-water ratio of 8:1, the highest ever recorded. An alien chemistry in our hands. Fifth, the observation window is limited, a race against time before it disappears into darkness, taking with it secrets we may never reach again. 31ATLAS reminds us of something profound. we are not alone in the void, not in terms of life perhaps, but certainly in terms of matter of worlds. It's tangible proof that our solar system is just one oasis in the vast cosmic ocean, and that this ocean is filled with fragments from other oases traveling through the darkness. Every star we see in the sky may have ejected its own comets and asteroids, billions of them, wandering aimlessly until they find a new home, or just a temporary passage, as Atlas does now. And in a few million years, when 3IATLA-S crosses another star system, perhaps other civilizations will observe it. Perhaps they'll wonder where it came from. Perhaps they'll detect traces of our star, of our sun, in its trajectory. And perhaps they'll wonder, ... is anyone there? The journey of 3IATLA-S is just beginning for science, but will soon end for us. To better understand the mysteries of these visitors from another world, check out our video on the enigmatic 1I Oumuamua or Comet 2I Borisov here on the end screen. The universe holds secrets beyond our imagination, and we are here to unveil them, one mystery at a time. Until next time, and may the darkness of the cosmos illuminate your mind.